Good morning, everyone. Thank you for being here today. When I say thank you, I say truly thank you, because when I was preparing this talk, I was thinking like, who will be crazy enough to want to listen to a random guy talk about JavaScript so early in the morning? So thank you for everyone being so crazy as am I and being here today. So in this session, we are going to be talking about elevating JavaScript interoperability. Because there has been so many updates from the last past months in Dart 3.3 and Dart 3.4 that bring a new way to interact with JavaScript inside our Dart and Flutter web applications. Before all this, I want to present myself. Jaime Blasco. I'm based in Spain. I'm a Flutter senior developer in a small startup called Hypervolt. I'm also a web developer in the technology and also part of the organization of Flutter Spain. I'm talking about this topic because mainly I maintain the Flutter Stripe package with some other colleagues, and recently I have to do all the migration to the new JavaScript interoperability, so I have to learn all the things that are new. So I wanted to share all with you all here today. So maybe for some of you that you were last year with me, it sounds familiar because I was giving a similar talk to the last year here in Fluttercon that was talking also about JavaScript interoperability. But the thing is, like, everything has changed so much in a year that I thought it was worth to share with you all the new updates and the new ways to interact with JavaScript. So in general, for the ones that you are not here, like, how many people have never touched JavaScript interoperability in Dart? Can you raise your hands? Never, like never. Okay, some of you. So for the ones that you are familiar with it, I hope you learn something new, or maybe if you haven't checked the migration, you will learn something. But in general, JavaScript interoperability offers a way to communicate with, like, your Flutter web app with all the tooling that is available for the JavaScript ecosystem. That is huge. Like, you can use all the browser APIs, you can use third-party libraries, and it has been for so many years that it has really amazing libraries that, either because it's very costly or it's impossible, we have not migrated yet to Dart itself. So any of you can have the chance to communicate with them and create a library that can communicate with that JavaScript library itself. But to understand where we are now, I wanted to go back a bit, understand where we're coming from, because I think it's worth to value where we come from, to value what we already are going to get with this new update. So it was around 2011 when Dart was launched, and by default it was ready for web. Like, everything was compiling to JavaScript since the beginning. So that's pretty awesome. But the communication between JavaScript and Dart was a bit bad. Like, imagine like two people that are from different countries, different languages, and they have to learn how to communicate between each other. So 2 years later, like between 1 year later and 2 years later, they exposed new libraries that will allow you to communicate with this JavaScript code. Like, first one, Dart.html, that allows you to expose all these browser APIs so you can communicate directly with them. In Dart.js, that you will be able to use your own JavaScript intercommunication with your own JavaScript code. But let's see how it worked before. Like, you have your variable in JavaScript, that is the thing above, that was like name, Jaime, and then you have a function. And then to access all these parameters in your Dart code, you have to use like the global context from the library, and then access parameters, names, methods, everything using a name. Return everything dynamically. So imagine like it was horrible to create an API that is stable using just that. So it evolved a bit, and 2 years later, they come up with this new package that was package.js that we have been using so far until now. It brought this JS annotation, and it allows you to create interface for the objects that we have in JavaScript. So for example, for this object, literal object that we just create user, we could now create an interface in Dart, more familiar what we are used to, that we will create getters, setters, and functions to access this Dart code. So something very familiar. Continue with Dart. In 2018, we are still like a long time ago, it sounds like yesterday, they released Dart 2.0 that brought soundness to the language. For those that you are not familiar with this, soundness means like when you compile the app, every type that you are expecting in the app is verified and ensures that it's correct. So before Dart 2.0, the types were mostly checking on runtime, so you could have some valid states where you were passing a type that was not the one that you were expecting, and your app will crash or it will give an error. So with this, you will verify with the analyzer and the build time, like your app was using the correct types. But of course, this took a bit more to arrive to the interoperability itself until now. So it has been a long path that we have been different changes that allow us to come where we're here today. The first one was like extension method that allow us to organize a bit better the code that in the way we use for JavaScript interoperability. And the most important one, it was static interoperability meta tag that set the basis and set the path to create a new interoperability that was static, type, and more sound for our libraries that we wanted to build. So this, it introduced a lot of changes to the system from outside as developers, but internally it brought so many levels like that it meant like a full rewrite of the interoperability itself to also be able to support other stuff in the future. For this came here today with Dart 3.3, that is now the future of JavaScript interoperability, that brings all the effort to bring a new stable JavaScript interoperability that is more familiar to Dart, is more safe to use, and is more like future ready. So all this was exposed to us through new libraries itself. We used to have Dart HTML, and now we will have the new package web, and we used to have package.js and Dart.js, and now we'll have to be using Dart.js interoperability. So let's see what these two libraries do. So the first library allows you to expose you the tools to create your own static interoperability. So it's a library, it's a core Dart library from Dart in the Dart SDK that is static, sound, and idiomatic, and allows you to create in a familiar way that we're used to in Dart, a new way like to create interfaces of your JavaScript objects or your JavaScript properties in Dart using extension types, a new feature that came also this year into the Dart language. And then we have package web that uses this all new technology to expose new browser APIs. It does the same thing that we have been using for 13 years in Dart HTML, but with all these new modern web technologies, also updating the APIs and everything to make it all supported for even web, like for JavaScript, and also being able to compile into Wasm. So with these new two libraries, we are going to set the basis of everything that we are going to build today. Let's start trying something that we want to create some JavaScript code, and we'll try to call it from Dart, okay? So for everything, like for this, we will create our own Flutter web app. If you come from a previous Flutter version, you will probably have to migrate your index.html. Is this, you can follow the guide here, but mainly what you have to do, there was an old script that was loading all the Flutter, and now you have to use this new script that is Flutter_bootstrap.js that is compiled when you build Flutter build web, and it set up all the resources to run your app in your browser itself. So now that we have created our app, we can just create some JavaScript code. We create a variable that's an URL, and then this variable is going to be our browser location, the URL. And then we're going to try to access this URL inside our Dart site, inside our Dart application. So we are going to use the new package that is Dart.js interoperability, and then to access a variable, we are going to use a getter with the same name, URL, and this getter is going to be external because we are telling this from outside, and it's coming from outside the Dart machine, and then the JavaScript annotation that tells you that it's coming from JavaScript because there is some other external methods that could be coming from native platforms like IO. And the type that we are assigning is like if we have a JavaScript string, we are going to use a new type that Dart.js interoperability provides, that is JS string. So let's talk more about these Dart JavaScript types. Let me drink some water. So in JavaScript, we have some core types that we can define like num, boolean, string, and we want to be able to use these types inside of Dart language. So this new library offers a new types that represent these JavaScript types. So first we have JSAny that is like represents any type of JavaScript object. It can be a primitive, it can be a function, it can be a promise. And then from there, we'll inherit all the other types that we can use inside of Dart app. We'll have our primitives that will be GS number, it will be a JavaScript number, GS boolean a boolean, GS string a string. I think you are getting it. And then we'll have GS object that will serve the base for any generic object that we might want to create. We already have some of them created, like we will have GS array, GS type array, all our GS JavaScript types, data view, promise, function, and some new ones that you are not familiar from JavaScript, but they are very useful to communicate between JavaScript and Dart. The GS exported Dart function means it's a function that it was a Dart function that you exported as a function to JavaScript, so you can call it to JavaScript Dart code. Something similar, you have GSBox Dart object, that is a Dart object that you can wrap it into a safe object from JavaScript to pass it also to JavaScript code, or external Dart reference that is something very similar to the box.object, but it just stores the reference of the object and you cannot use it in JavaScript itself. Something very related of the types is to understand that nullability means different from JavaScript to Dart. Like in JavaScript, there is two types of nullability. You have undefined and null, and it means like a variable cannot be defined. Like you can try to access a variable that is not defined, or you can try to access a variable that's defined, but the value itself is null. For both of them, Dart will interpret that they are null. And this is because there is no way to do this on the Dart side, and also because the Dart team itself recommends this because to make it future-proof to Wasm itself. Because in Wasm, when you compile your app into Wasm, all the undefined values are automatically assigned to be null. So you don't want to have inconsistencies between JavaScript interoperability, like into values that are different from JavaScript to Wasm. So in this case, we'll try to assume in all our use cases that undefined and null probably will mean the same in our Dart code. So now that we have understand that we can represent all these types that they are from JavaScript into Dart, we might want to use like this GS string to be a Dart string. Like how can we make this conversion between a JavaScript string in our Dart code to a Dart string in our Dart code? So for this, we have a series of conversions that usually is one-to-one. So we are going to show a table here, and I think it's quite straightforward. Like GS number will be able to be converted to num, int or double. GS boolean will be able to be converted to boolean, string to string, function to function, array to list, promise to future, type of arrays to type of arrays, and then the reference of Dart objects in JavaScript will be able to be converted to generic objects in Dart. To make these conversions, is very straightforward. So let's see an example here. For example, you want to convert from a string to a JavaScript reference of this string. So you will create a string there, and you have a static method that was created in the library itself that you can call in whatever of these elements from the Dart type, and you can call to GS, and it will automatically convert to his simil in JavaScript type. If we want to do the opposite, we can have a JavaScript string that we access from somewhere else, and then we want to convert it to Dart so we can access anywhere else. If you're asking for GS number, you can convert it and you can do to Dart int, to Dart double, or to Dart null, depending on what type of you want to convert. Luckily for us, the Dart language itself, when you compile it, it will automatically convert for you all the primitives that you use directly. So for example, if you want to access a JavaScript library, like a JavaScript variable that's a string, you can define it as a string directly on our Dart code, and during the compilation, it will do the automatic conversion itself. So for example, we were seeing before that we just create this getter that was a GS string. We just can safely use a string there because it will do automatically conversion for us. Let's continue with this. Now that we have a getter, we could also set a setter, but let's do a method itself. We declare the method in JavaScript, and then we give it a name, we pass a parameter that is a message, and we will display this native alert. We call this native JavaScript method that is alert that displays a native alert from your browser. So to try to call this method from our Dart app side, we'll have to do like something very similar. We'll have to define the interface of the method itself. It doesn't return anything. The name is createAlert, and then the parameter is string message, and then again tell it is an external method coming from a JS annotation. So with this, we just could call this JavaScript code directly from Dart. So in our main, we call createAlert, we pass a message itself, we can even pass the URL that we get from JavaScript itself, and this will run out and then will display like, hey, welcome to Fluttercon with the native alert itself. But as we can see, we have window, we have location, we have the method alert. All these are browser APIs that we have seen already, like there's something that the browser provides to us, and we mentioned before that we can use the package web to do that. Like the package web creates already the interfaces for all this to be used directly into Dart. So the same as we did before, but in a better way, the package web offers for us directly in Dart. So that's the idea, like there's a person or some developer that create a library that creates this interface of a JavaScript API and offers to other developers in Dart. So in this case, we have a nice way to call JavaScript APIs using Dart, like we window.alert, and then we pass the same parameters as before. But okay, we know how to do use JavaScript types, but we are missing something big. Like what is? Like we have here that's window. Window is an object in JavaScript, and we haven't learned yet how to create these JavaScript objects in Dart. This is completely new here in Dart 3.3 and is built with type extensions. So let's try to explain a bit what is type extensions in case you never read about it. But types extensions is a new language feature that came in Dart 3.3, and it offers a way to abstract an interface, like an existing interface, like an existing type, like for example a string, and create a new interface that is static and different from it during compilation time. So, like for example, here we have our app, and we identify our users using an ID, but we don't want to expose the rest of the developers with the same ID because using the type string, because they could use some random stuff, like they could get the characters of the string, they could check the length of the string, and we want to limit the scope of what the developer can do with this type. So instead of using type string, we are going to create this extension method that is going to be called user ID that limits, if it's going to still be the type during compilation, it's going to still be a string, but during the development process, it's going to have this new static type that is called user ID that limits what the user can do to this new property that we just defined. So in this case, we will define a new property that is, okay, the developer can only check that the user ID is valid if the length is equals 9. So when you are using this in your app, you could be able to create the new type there and then check if it's valid or not, but you couldn't access anything that is a string. Even during compilation time, this variable will be a string. So it looks like a lot like a wrapper class, but the benefit of this, it doesn't have, you don't have to do the cost of creating a new instant object every time you want to create this wrapper. And maybe for one it's okay, but when you want to have multiple objects wrap, this consumes a lot. So in this case, something that we could also do is, like, if we want to extend, like we want to create this extension type, but still offer the possibilities of the previous, like the real interface of the type, like we want to developers access new properties, but also access the properties from a string, we just will need to implement the current type. Like we will do implement string, and the developer could access the new properties and the old ones. So why are you telling me this about in a talk about JavaScript? Because this, I think, is perfectly what we need for JavaScript. We have an existing object with a weird type that we don't know. In this case, it's a string. In our case, it's JavaScript object. And we want to create a new interface completely from new, but have zero cost during development. We don't want to have a class in JavaScript and a whole wrapper that we have to initialize in Dart. We just want to create an interface that has zero cost that will allow us to call directly to our code in JavaScript. So that's what we're going to use. We are going to use extension types to create the representation of our objects from our JavaScript code. So let's see an example here. We have a class in JavaScript that is class user. There is an object itself, and then we are going to try to define that same interface in our Dart code. So we will create an extension type with the same name user, and we tell them it's extending the real type object, that is GS object. We are going to tweak it a bit to make it more usable for us in our daily on our daily development. We are not going to use the variable GS object, so we are going to make it private. Same for the constructor. We are not going to ever initialize this type extension with the GS object, so we are going to make it private too. And then we are going to implement, as we say, the JavaScript object, because probably at some point we want to reference this variable as this variable, like this type user, as something related to JavaScript itself. So it's recommended for everything that we use with JavaScript objects to implement also itself, the JavaScript object. Let's see, imagine we have in JavaScript, we want to create a constructor. So we pass two parameters that assigns to name and value local properties. So if we want to do the same for our interface here in Dart, we'll have to do something very similar. We'll create our constructor for the type extension that will pass two positional parameters, name and email, and then again we have to define that is coming externally because the initialization is happening on JavaScript. Something similar, if we wanted to create a setter, a getter, a method, we will define it first in JavaScript, and then we will have to create the interface in Dart itself, external, and then the interface of a getter, setter, or a method. We can also create interfaces for something more complex, like we can create interface for a static method or a static variable. So for example, this JavaScript code has a static anonymous that assigns a null value for a user if the user is not authenticated. And we can just do the same, like we do external, static, and we create an interface of a getter that is static for being able to access it through our Dart code. And with this, we could also, we could already initialize the user, that is a JavaScript object, and then call the display details, his method, and it will display the banner itself there. So is this, there is not much complexity, but we still can tweak it a bit to make it more usable for our developers. Like, for example, we don't want to expose, if we want to share this in a library with some users, we want to make it clear that the user is referencing a JavaScript variable. So we will put GS user, we rename it to this variable, so it's obvious it's a JavaScript variable. So we'll rename the variable, but we'll have to use the annotation and put the real name of the object in JavaScript, so the compiler understands you are referencing to this object prototype. Something similar, like Flutter developer, we are more used to work with name parameters instead of positional parameters. So we could even create a private, convert this to be a private method, and then create a new factory constructor that provides a more familiar way to use our APIs. Like for example, we will be able to create a factory that has two name parameters that are required, and then so when a user, like a Dart developer uses our API, it will be more familiar or obvious for them what are they building. Before we finish with these examples, I wanted to bring up something that we talk about, that is conversions between lists and arrays. I think it's something not straightforward at the beginning, and it will be very meaningful to show an example here today. So let's example here, our email is going to, our user is going to support different emails instead of one. So we are going to accept now, instead of a GS string, we are going to accept a GS array of strings. So again, we will have a constructor that is going to be two name parameters, name and strings and emails. And email is going to be a GS array of GS strings, because that's what we want to pass to JavaScript. But of course, this doesn't look very nice to a Flutter developer. So we are going to make it private and not expose it to everyone, and limit to that class, and then create another factory constructor here where we are going to do the conversion. So we ask the developer to pass us a list of strings, and we are going to convert it to a GS array of GS strings. So the conversion is going to do in two steps. First, going to move from list of strings, we are going to change all the parameters into a list of GS strings, and then once that we have a list of GS strings, we can do the parsing between list and array, and then we'll have a GS array of strings. So it's a bit complex, but once you got it, you can create a static method extension that helps you with this, and it will be very straightforward. But you have the list of strings, you map every time of that is a string to a GS strings with 2 GS, and then you have a list of GS strings, you can convert it to an array. Something very similar if we want to do the opposite. If we want to access the emails property from the JavaScript object, we'll have to get it as a GS array of GS strings. But again, we want to expose it to the developer as a list of strings. So we want to hide this because it's very complex for them. And we are going to make a getter that is public, and what it does is converts these emails that is a GS array, it converts the GS array to list, and then now that we have a list of GS array, we will be able to convert it directly to a list of strings directly. So with this, we are able to use a library, read the documentation, get the API, and then try to create the interface with Dart. Let's see an example of how can we do it here today. Like for example, I wanted to create a website that it display my videos of my live recordings of my sessions during these last years. So I wanted to use a video player, and I didn't like the video player from the plugin itself from Flutter because it's the native video player, and it has it renders differently in different devices because it's the native player from the browser, and every browser has a different video player. So I came up with this library, this Clear.io, that is really cool because it has this amazing UI. Everything is built by from scratch, super useful, super intuitive, allows you to do a lot of controls. So let's see if we can try to use that in our Flutter app. The first thing I will do if I want to use any JavaScript library is to see if the documentation is something I can understand and everything. So the first thing that they told us is you have to add a video tag in your HTML document. So something like this, you have to add a video, and then you put the ID, you set the controls is true, so the controls appears, and then you set the source. Let's try to do this with Flutter. So Flutter, to add an element inside our Flutter app, inside our Flutter web app, we have this widget. I don't know if you ever use it, but it's called HTML view. We are going to use this constructor that allows you to create this HTML view wherever you want in the widget tree using the tag name, using a custom tag name. So in this case, we are going to give the tag the name custom video player, and then we have this callback that tells you when this element has been added to the DOM tree of your web app, and then also when it's added, and gives you a reference of the element here so you can use it. So now that we have our own element here, we are going to add a video inside. So we are going to create a child that all this is from the package web. So we are going to have a HTML video element that is a JS object, and then we set the ID, we set the controls, we append the source, and then we'll have to add this element inside our HTML view that we already created. Right now we have to cast the element, element as HTML element, because on created from the Flutter package itself, it returns dynamic, it returns a generic object to allow us to support the old interoperability and the new one at the same time. Because otherwise, forcing that to be HTML element will be a breaking change that involves every app that is not ready for migration to the new interoperability. So in this way, you can still use both old and new one, not at the same time, but doesn't break your app. So now with this, we'll be ready. We'll have our video in our app. We don't need to do anything else. We have a native video inside our app. We don't have to use any package. We don't have to use anything else. But as we said before, we are going to use this new library that is really cool. So the thing that documentation says is you have to add your JavaScript code into your head and also the style sheet. So we will add this in our index.html. We have the JavaScript code and the CSS file. And then the only thing that we need to do here in the library itself, it says you have to create a new object that is clear and tell with the selector, like we are using the ID player, to tell which element you want to create the video where. where is the source where you want to create the video. So we just need to do that. How we create the interface for the player object, we are going to use an extension type, as we saw before. So we just have to create the extension type player that extends a JS object. There is only one constructor with a string as a parameter, so we create a constructor with a string as a parameter. Then, as same as we initialize it here, we can initialize it in Dart, so it's final player equals player, and we already, like with this line of code, with these 3 lines of code, we'll be able to use the library inside Dart. So let's see, for example, here, we will be able to we will be able to have our app here, and then we can even like extend the functionality in the future with more method itself. So if we see like the code itself, I think it's worth to explore a bit how is it built. We can check like that what we have here is a platform view, so it's the widget that we created is added as an element into the DOM, and then we have this element that we create ourselves, like the one that was like from tag name, and we have our tag name here, like we have custom video player, and this div that used to be a video element, the library itself has replaced it with their own components that renders the video itself. So in this way, with one line of code, if we were to wanted to use the native one, we will not need to call the player element itself. We will be able to hide it. So to hide this, and what we saw before, like we have our HTML view with the tag name, and then we add the video, and we will be able to have a native video that looks different in every browser. Now that we have this player object, I wanna, before we finish, see some tricks that we can use when we are designing a Dart library using JavaScript interoperability. A lot of library itself allow you to use different types in the constructors. So allows you, for example, to pass a selector of the element itself. So it finds the element by ID, class, or whatever, and also allows you to use directly the element itself. So it's same constructor with different type of parameters. That is not possible in Dart, but what we can do is like have different name parameters from selector, from element, and then reference both with the JSON annotation to the same constructor. So in this case, both will be calling the same one, but with different parameters. One the string, and the other one directly the reference of the element itself. Another thing that the library allows is you can add optional parameters after, like you can put a title, you can add thumbnails, a lot of stuff. So you do this by passing another parameter that is an object, but this is a different object. I don't have time to explain more about what is this kind of object, but it's called object literal. That is an object that doesn't have a prototype, it doesn't have an interface in JavaScript. So you just create it. The more similar thing that we have in Dart is a map, but the map doesn't allow to have methods, but it's something like a map, right? So we could do the trick here, and it's like, as it's something optional, we could pass it as an optional parameter here in the constructor. And when we initialize it, we could use a map with the properties, and then call this extension that is very useful, that is called gcify, that what it does is converts any Dart code into JavaScript code. It has some restrictions, that's why it feels like a bit of cheating, because it only allows to convert into JavaScript anything that is a map, a list, or any JavaScript type, or a primitive, sorry. So imagine if you want to pass a widget here and then you call it gcify, it will totally break during compilation time. But if you want to do it before, you could definitely, like if you just want to do something simple already, you could do it. But the proper way to do it will be like, again, it will be creating another extension type for just this object prototype. And when an object, like when we want to create an extension type of an object that is an object literal, that is the one that you construct without a prototype, without any constructor. The only difference that you will have to do is to create the prototype, the constructor, you will have to have name parameters. So when object in JavaScript has a prototype and it has a constructor, you will use name parameters. And if it's an object literal that doesn't have a constructor, you will be using name parameters, very similar syntax that the one we have in JavaScript itself. So the coolest thing about all of this is like with these new two libraries, everything that we built today is ready for WASM. So everything that you just are compiling, if you use the WAS tag, you can compile it directly to WASM and the video will render the same with the same capabilities. I pushed the asterisk because of course it's something in progress, so there is issues, and I encountered issues while building this beta in WASM. The only thing that I encountered, it was that the video was displaying but in a different scale. I think it was more a problem of the HTML view more than the JavaScript library itself. Just to recap, I think the main concept I want you to remember today is like, we have these two new libraries. There is direct JavaScript interoperability that allows you to create the interface of a JavaScript library into our Dart app, and then package web that does just the same as that, but with all the browser APIs already available for you. Then the way to create an object interface in our Flutter app or in our Dart app is going to be through the new type extension types. So you will give it the same name as your JavaScript object, and then you will extend JavaScript object type, and you can create whatever constructor, properties, values, getters, setters that you might want to use from your JavaScript code. It's not needed to implement all of them, just the ones that you think they are useful to use. And with this, thank you so much. I hope you can learn some today, and you can see the code here, and I probably will share the slides on Twitter.